Hello, my name is Oro Garcia, and today I'll be doing my shoe size analysis for my AP Statistics Online Project 1. So the main reason of normal distribution. A normal distribution is a bell-shaped frequency distribution curve. Most of the data values in a normal distribution tend to cluster around the mean. The further a data point is from the mean, the less likely it is to occur. There are many things such as intelligence, height, and blood pressure that naturally follows a normal distribution. So here's the data of the shoe size. I got this from the data that we collected for that spreadsheet. And for that one, I pick shoe size as the quantitative variable. So for the mean, I added all of the numbers together, the 13 numbers together, and I got 106.5. And then I divided by 13, which is the number of numbers. So 106.5 divided by 13 is 8.19. And that is rounded to the nearest hundredths. So here is how to find the standard deviation. So on the top left corner is the equation of how to get the standard deviation. Over here, the data or the table, you can see on top the value, mean, value minus mean to the power of 2, and the sum of value minus mean squared. After that, you need to find how many there are, or how many data points there are, which is 13, and the square root of the sum divided by 13. So the answer I got is 1.67, and that is rounded to the nearest hundredth. So here's the other data point that I collected. And this all adds up to 13. So here's the normal distribution. This is standard deviation. The first standard deviation is from 6.52 to 9.86. The second standard deviation is 4.85 to 11.53, and the third standard deviation is 3.18 to 13.2. Note that the mean is 8.19 and the standard deviation is 1.67. So I will have to add 1.67 and subtract 1.67 to find the standard deviation from the left and to the right. So here is how it looks like. So 8.19 is in the middle, and 6.52 to 9.86 is 68% of the data in the normal distribution. From 4.85 to 11.53 is 95% of the data, and 3.18 to 13.2 is 99.7% of the data. And the others is 0.15% for both sides, so that is 0.3%. So here is the actual distribution from the data points. So from 6.52 to 9.86, there are actually 10 out of 13 data points, which is equal to 76.92%. As for the 4.86 to 11.53, which is the second standard deviation, it is 12 out of 13 data points, which is 92.31%. So as for the 3.18 to 13.2, that is the third deviation, which is 13 out of 13, which equals to 100% of the data points. So here's my analysis. Since the mean of the data is 8.19 and the standard deviation is 1.67, then the normal model states that 68% of the data should be between 6.52 and 99.86. 95% of the data should be between 4.85 and 11.53, and 99.7% of the data should be between 3.18 to 13.2. The actual data distribution shows that 76.92% is in the first standard deviation, 92.31% is in the second standard deviation, and 100% is in the third standard deviation. I believe that this is a good estimate because the data is unimodal and looks symmetric. The averages for each deviation are also close to each other. So for this first standard deviation, it is 68% for the normal, and for the real data points, it was actually 76.92, which is close to each other. And for the second, it's 95%. And for the normal, I got 92.31%, which again is close to one another. And for the final one, the third one, I got 99.7% and 100% for the normal distribution. So I believe that this is a good estimate.